Welcome to this video about the MC Next software, where we take a look at the field layout workflows using CAD. My name is Randolph Reumer, software developer at Mouse Software. Okay, in this video we will cover the following topics. First we start with the settings, specifying point groups and start numbers. Then we will take a look how to manually insert points, dynamic and by quadrant. There are also automated tools in the plugin. We will see how to insert points in blocks, a powerful feature where you embed points into a block and automatically generating points throughout these blocks in a drawing. Then we will take a closer look at the auto insert wizards over lines, circles and points. We will see how to set up control, how to apply a corner system by specifying two base points, point A and point B, in a drawing. And these 2 points will represent your new corner system without changing the drawing. Then when we have set up control, we will take a look how to input points from a robotic totalization and how to export a background file and points to a robotic totalization as well. And finally, at the end of this video, we will see how to handle as-built surveys, how to generate deviations in CAD, and how to generate a point comparison report. Alright, let's get started. Before we begin in CAD, let us take a brief look at the general settings of the MC Next software, which you can find at the ribbon Quick Access toolbar. Here you can select the language for the software, as well as specifying a project location for your new projects. It's a good idea to specify a project location so you don't have to navigate to your project folder each time you save a file. On the Units tab, you can specify a coordinate order, as well as the MC Next units. The MC Next software will convert the coordinate data as well as the background file from the CAD drawing units to these MC Next units, so be sure to set it correctly here. Then on the CAD BIM program tab, you can select your CAD version. In this video we will use AutoCAD 2015, but you can also use AutoCAD LT, BricsCAD or ZWCAD versions with the MC Next software. We can press OK, and now that we have specified the settings, choose Prepare Points in CAD Revit to start the CAD software. Okay, now that AutoCAD is started, you can find the MC Next plugin in the ribbon. And I just opened the entry level of the Revit Advanced sample project, which I exported in Revit in DWG file format. To start adding points to the drawing, let us first check the snap functions by keying in Object Snap on the command line. And be sure to select only the snap functions that you need. And then we can choose settings to specifying a point group and a start number. For new group, we key in walls, and then click add. And for start number, we choose 1. And then we press OK to apply these settings. To manually insert points, we have the Insert Points option. For now, let's choose the first option, Insert Points Dynamic. And then we can zoom into this wall, for instance, and click to add some points to this wall. And as you can see, you can specify location of the point number. You can change the settings while you're placing the points, as you can see here. So to add a description for the points, for example, key in the D of description. Enter a point description, let's say wall, and then press enter. And now you can continue placing points. And to exit the command, you have to press the escape button. Now let us take a look at the automated tools. And we start with the auto insert points over blocks, where you can select a block and automatically place points on the insertion points of these blocks in the drawing. We see here, for example, 7 concrete round columns. And when you zoom in and you select the block, you see also the insertion point of that block. To place points on the insertion points of these blocks, we're going to choose how to insert points over blocks. And we select the column. And for select objects, we drag a window around the area that we want to use for the auto insert wizard, and then we press enter. The wizard comes up. We're gonna specify a new start number for these points. We see here the concrete round column, 7 in total, and we're gonna key in a new group, concrete columns, and we press add. You see here the settings for the points, and you can choose a numbering route if you like. We see a review of the points, and at the end we can click finish and update the drawing to add these points to the drawing. So we click finish, we choose update drawing, and as you see, the points are added to the drawing. You can also auto insert points in blocks, where you embed points into the block itself. To see how it works, we choose auto insert points in blocks, and let us zoom in a little bit, and for now we select the universal column. The block will be loaded into the block editor, and a little toolbar comes up where you can insert points into the block, and when you're done you can save these points. Before we insert points, let us first add 2 offset lines to this block. That will also be useful outside in the field when we lay out these columns. To do so, we key in offset on the command line. For distance, we key in 500 millimeters. Select the center line and add an offset line on both sides. We press escape to exit the command and choose insert points in block. First we select the center point of the column, and then we're going to place points on the offset lines. When we're done, we press escape to exit the command, and we choose save. This will bring up the wizard. We're going to specify a new start number for these points. For a new group, we key in universal columns and click add. For the settings for the points, for symbol size, we key in 100, and for the same for text height. Here we can specify a numbering route. We see a review of the points, and at the end of the wizard we can choose finish and choose update drawing to add the points to the drawing. So we click finish, and then we choose update drawing, and as you can see, the points are added throughout these blocks, including the offset lines. Now let us take a look at the auto insert points over lines, and we begin by placing points on the intersections of the grid lines. To do so, we choose auto insert points over lines, and for select a line we select a grid line, and for select objects we're going to drag a rectangular window around the area that we want to use for the auto insert wizard, and in this case we select the entire drawing, and then we press enter. The wizard comes up, we choose intersections, and we're going to specify a new start number for these points. We see the layer of the grid lines, and we're going to key in a new group for these points, grid, and then click add. We see here the settings for the points. You can choose a numbering route, and we see at the end the review of the points, 127 intersections in total. And at the end of the wizard we choose finish and choose update drawing to add points to the drawing. So we click finish, and then we choose update drawing, and the points are added at every intersections of the grid lines. You can also use the auto insert over lines wizard to get the contours of a floor. To see how it works, we choose auto insert over lines, and we select the line of the floor. Then we zoom out a little bit and drag a rectangular window around the area that we want to use for the wizard, and then press enter. The wizard comes up. We choose endpoints, and we're going to specify a new start number for these points. We see the layer of the floor. We're going to key in a new group, floor. Then we choose add. We see the settings for the points. We don't use any numbering route, so it follows the contours of the floor. We see a review of the points, and at the end we can click finish and update the drawing to add these points to the drawing. So we click finish, and then we choose update drawing, and the points are included. To get the center points of the columns on the entry level, we can choose the auto insert points over circles or points, and we zoom in a little bit and select the column. For select objects, we zoom out and drag a rectangular window around the area that we want to use for the auto insert wizard. And for now we select the entire drawing and then press enter. The wizard comes up, and we're going to specify a new start number for these points. We see a list of the columns. We're going to key in a new group for these points, columns, and then click add. We see here the settings for the points. We can choose a numbering route, and here we see a review of the points, 63 columns found. And at the end we can click finish and choose update drawing to add the points to the drawing. So we click finish and we click update drawing, and the points are added at every center points of the columns. Now that we have added some point groups, let's take a look at how to make some changes. To do so, we choose edit points, and you can delete or edit a group. For now, let's edit the columns group, and here we can make new settings for the point group, and let's add a new description, columns. You can store it in a different group if you like. You see a review of the points, and at the end we can click finish and update the drawing to update these new settings. So we click update drawing, and we see the points are updated with a new point description. Now let us set up control and apply a coordinate system for this drawing. To position the drawing to the real world survey point in the field, we're going to use the define coordinate system wizard in CAD. To do so, we're going to use two reference points that are measured by the surveyor in the field, and make these two reference points present in the CAD drawing, so we can snap to these points. In this example, we're going to use the two corners of the building here. And when we zoom in a little bit, we see point 454 is the corner of the building here, and is measured by the surveyor in the field and labeled as point 2001. And the other corner, as you can see here, is point 453 and is measured by the surveyor in the field and labeled as point 2002. To display the total distance between these 2 points in the drawing, we're going to key in distance. I'm going to measure these 2 points. So can we see here that the total distance is 54 meters and 9 millimeters. Now let us take a look at the corners of the measured points of the surveyor. So first we're going to go to the MCNX software, and we're going to open the file of the surveyor. And we see here the actual coordinates of the surveyor that is using for the two reference points, 2001 and 2002. We see 2001 has an x coordinate of 1 meter, and a y coordinate of 10 meters. And we see also the coordinates of point 2002. These coordinates we're going to use in a minute, but let us also take a look at the total distance and true north between these two reference points. So we'll go to the graphic view, and we see here 2001 and 2002. So we're going to inquire the distance, 2001 and 2002. And we see here that the distance between the two reference points is slightly larger when you compare it with the design, 3 millimeters in total, and the azimuth or true north is 10 degrees off. So we go back to CAD, and to enter the coordinates of the surveyor for these two reference points without changing the drawing, we choose Define Coordinate System. This will bring up the wizard. We click Next, and then we click Advanced to enter the new coordinates of the surveyor for 2 points in the drawing, point A and point B. So for now we going to select the first corner of the building. Let's measure it here. Was labeled 454. So we'll go to the point group floor and we select point 454, and we say this will be point A, and we're going to enter the coordinates of the surveyor here in millimeters, so 1000 and 10,000. Point B is on the other side of the building, 453, and we select it as point B, and we key in the corners of the surveyor. That was 10,379 and 63192. Then we click Next, and we see here the review of the coordinate system settings. Rotation is 10 degrees off, and difference in distance is 3 millimeters for the new coordinate system when you compare it with the old coordinate system in the drawing. So we click Next, and we click Finish and update the drawing to add these two base points and the new coordinate system into the drawing. So we click Update Drawing, and we see now the two base points, point B with the new coordinates of the surveyor, and also point A, 1 meter and 10 millimeters, and this will be now the new coordinate system to lay out the project. Now that we have set up control, we can import files from the field into the drawing. Let's import a file from the surveyor by going to the MCNX software. So here we are in the MCNX software, and I just opened the file of the surveyor. So we're going to select all the points, and we're going to copy and put these points on the clipboard. Then we go back to CAD, and we're going to select Insert Points from Clipboard. This will bring up the wizard, 11 points found. We're going to key in a new group for these points, Control Points, and then click Add. We see here the settings for the points. We can make some changes. Click Next. We're only going to import the points. We see a review of the points, and at the end we can click Finish and update the drawing to add these points to the drawing. So we click Finish and update the drawing, and we can see now the points are added to the drawing, the reference points of the building, and also the control points that the surveyor is using to lay out the project. To export the points to a robotic total station or GPS receiver, you have the options Export Points and Export Background File and Points. When you choose Export Background File and Points, the current drawing in DWG or DXF format will also be exported and scaled to the MCNX units. Let's export the current drawing and the points to the MCNX software by choosing Export Background File and Points. The background file will be created and the points will be loaded in the MCNX software as we have created in CAD. To export the points and the background file to a device, you can choose Export to Device. Here you can select the point groups that you would like to export. For now, let's say grid and control points. We're going to key in a file name, entry level, create separate files by group, and we're going to include the background file. Then we can click Explore Project Folder, and the files will be put on a clipboard. And we're going to create a new folder, entry level, and we're going to paste in these files. As you can see, we see the background file in DXF format and the point group files, which we can load into the robotic total station. When you have as-built surveys, you can generate deviations, display these deviations in CAD, and create a point comparison report. To do so, let us first open an as-built file from the surveyor. And in this case, we have an as-built of the columns on the entry level. We select all the points, and we're going to put these points on the clipboard. And then we go back to CAD, and we choose Generate Deviations. This will bring up the wizard, and here we can select the point group that contains the design points, in this case columns. So we click Next, and we can specify the settings for the point comparison. For tolerances we use for XY 10 millimeters, and the same for elevation. Here you can specify the radius for reporting points. You don't have to worry about that the measured point IDs have to match with the design point IDs. From the measured point, it will search within the specified radius and use the closest design point that has been found for the point comparison. Here you can specify the alignment and a 2D or 3D comparison. For now, let's choose 3D comparison and click Next. Then we see the results. Column 501 is to the right 3 millimeters and down 2 millimeters. We can also see the points above tolerances, and we can click on Preview to generate a report with the explanation of the used symbols, the summary with the minimum and maximum values, and the report itself. When you click Next, you can specify the deviations in CAD. All the points or points above tolerances only. For now we keep these settings, so we click Next. We can mark the points above tolerances with a cloud, so let's say 2500 for symbol size. We click Next. We see a review of the comparison results, and at the end we can click Finish and update the drawing to add these deviations to the drawing. So we click Finish, and we zoom in a little bit so we can see it. And then we choose Update Drawing to add these deviations to the drawing. And here, for instance, column 501 is to the right 3 millimeters and down 2 millimeters, and 3 millimeters in elevation. You can also quickly see the deviations above tolerances. So here we have a cloud symbol, and we see a deviation above tolerances, in this case 11 millimeters in elevation. So this is a way you can quickly see the deviation above tolerances, which may probably cause problems during construction. Okay, thank you for watching this video about field layout workflows using CAD. I hope it has given you a good overview. You can download a free 30-day trial from our website. It's not limited in any way from the full version, so be sure to download a copy. If you have questions, please feel free to contact us at support@mousesoftware.com. And again, thank you for watching.